Hello, fourth year. We are going to have a look at Pythagoras' theorem. So we're going to leave ratio behind, and we're just going to focus in on Pythagoras' theorem. Now, Pythagoras' theorem probably isn't new. You've certainly heard it before. You may not feel confident with it. That's okay. We'll get a bit of practice under our belt now, and we'll see how we go. There are, well, one important thing that we have to get to grips with first of all, which is that Pythagoras' theorem can only be used with right angle triangles. Okay, so don't try and use it on any other triangles. There's got to be a right angle triangle. So that's the kind of first thing. The next thing we need to know is how to correctly identify what's called the hypotenuse, okay, which is this word up here. All right, now the hypotenuse is always opposite the right angle, and it is the longest side. Okay, so in this example over here, this is the hypotenuse. I'm not happy with my H actually. I always just abbreviate that to HYP. Okay, so hypotenuse. I don't want to write that word every time, far too long. So I just abbreviate that to HYP. Alright, the other two sides, it's less crucial what we call those, to be honest. So I tend to just label those up as sort of side A and side B. Okay, now, so far so good. That is assuming I don't know how big they are. This over here, these kind of pictures where you can see the three squares, I'm sort of looking here now. These are a pictorial representation of what Pythagoras' theorem says. Because Pythagoras' theorem says that the hypotenuse squared is equal to side A squared plus side B squared. Okay, so in other words, this large square would be equal to these two smaller squares added together. Right, that's what Pythagoras' theorem says. So the sum of the two small sides squared is equal to the hypotenuse squared. That's what that theorem actually tells us. All right. Now the practical implementation of that is really what we want to focus on, and we're going to focus in on calculating the size of this side here, so the hypotenuse. All right, that's what we're going to focus on for today. We're not going to worry about calculating side A or side B. We're just focused on calculating the hypotenuse. So the first thing you should do with any Pythagoras question is draw a sketch. All right, now please use a ruler, because you really can't draw a right angle triangle without one. But you should draw a sketch, and you should label up your sides, okay? Now, I'm just going to use a slightly different colour to label up my sides here. So I'm going to go, I've already got that pen up there, let's use that one. This is the hypotenuse, okay, so that's HYP. I'm going to stick with this being side B down here, and this one side A. It really doesn't matter whether you call it side A or side B, that doesn't matter. The thing that you, excuse me, the thing that you cannot get wrong is the hypotenuse, because the hypotenuse is always opposite the right angle. That is the thing you must get right. All right. The next thing you need to do is write down Pythagoras' theorem, which says, like I said in the pictures above, the hypotenuse squared is equal to side A squared plus side B squared. Now I know how much some of you don't like writing things out. I'm afraid my answer to that really is too bad, so sad. Never mind. You need to write out the theorem. The reason I'm asking you to do that is, number one, it might trigger a mark in an assessment because it shows that you know Pythagoras' theorem. Number two, it helps put it into your mind and into your brain, which is exactly where I want it to be. I want you to remember Pythagoras' theorem, and I want you to remember it in this way. So please, just write it out, okay? I could possibly live with you abbreviating side A squared to just A squared and side B squared to just B squared, but that's it. I want you to write out hypotenuse squared is equal to A squared plus B squared as the absolute minimum. Okay, the next thing you want to do is just put in the values. Now, the hypotenuse in this example is called T. So we'll call it t squared. Side A squared is equal to 15 squared, and side B, as it happens, is also equal to 15 squared. Okay, so the two sides are not always going to be the same size, they just happen to be in this question. So t squared is equal to, let your calculator do the work for you, and you will discover that 15 squared plus 15 squared is 450. Alright, now, next thing you should be asking yourself, well, how do we do... I don't want t squared, do I? No, I do not. I want t on its own, so I have to take the square root of 450. And if I take the square root of 450, again, let your calculator do the work for you. It'll come up with a surd, so 15 root 2. If you press your SD button, you will get a decimal number. Move that down. And I'm going to round that to 1 decimal place, I think, so 21.2. I'm working in centimetres, and that's 1 decimal place. Okay, so recap what we've done here. Write out the formula. I'm not a big fan of that yellow highlighter. Let's make it green again. I prefer that. So, write out formula. Substitute in values. Use your calculator to do the work for you. Okay, 15 squared plus 15 squared is 450. Take the square root of both sides. Press your SD button if you get a surd answer and you want a decimal answer, and then round your answer to 1 decimal place. In a lot of cases when you do Pythagoras, you're going to get a decimal answer, so you'll have to round most of the time. Alright, so those are the steps, those are the stages. Let's do this next example. You can see that the orientation of the triangle has changed here, alright? So instead of it being one way, it's another way. That doesn't matter, alright? Your triangles can be orientated any way you like. The key thing is that you label things up correctly. So the first side to do is the side that's opposite the right angle. Mark that as the hypotenuse. And then side B and side A. Okay, again, doesn't matter whether you've got A and B round the other way. The key side that you have to get right is the hypotenuse. Okay, now, remember, write out Pythagoras theorem. And I don't care about you having to do the writing. It's really not that difficult. How many letters do we have there? 1, 2, 3, 4. An equal sign, 5. 10. 10 letters and symbols. Not too difficult, is it? Piece of cake. Right. Hypotenuse is represented by the letter M this time. Okay. So we're substituting in our values. A was 17. And B was 11. Alright, so M squared... Again, let your calculator do the work for you. So 17 squared plus 11 squared is 410. Okay. Take the square root of both sides. 410. Again, let the calculator do the work. So square root of 410 is going to give me 20.248 and lots of numbers after that. So M is... a rounded answer is going to be 20.2. Again, that's just 1 decimal place, and I have missed out the most important thing. Units, please. Okay, make sure you always include units. 1 decimal place. Put my double underlines up here as well. Okay, exactly the same approach as we took last time. So, write out Pythagoras theorem. Substitute in the values from your sketch. Let your calculator do the work. To find M on its own, you have to take the square root of both sides. Final answer, rounded answer. Okay, those are the steps. It is a very mechanical process, Pythagoras theorem. Okay, we're going to move into using Pythagoras theorem to find the shorter sides and 3D Pythagoras and different things. But first thing we want to do is get to grips with this. Okay, this is the approach that I want you to take. I really want this to sink in. Please, please, please know Pythagoras theorem. and make sure you know what the hypotenuse is, all right? It's opposite the right angle. If you get that wrong, Pythagoras theorem goes wrong, okay? If you get the hypotenuse right, that is a great start, okay? I hope that video is useful. I'll be available to answer questions for you Tuesday from 10:25 until 12:20, and then the same again on Friday. If you contact me outside of those times, I will try and get back to you. It just might take longer. Teams chat is fine, or Glow email is also fine. Please contact me in either place. I really don't mind which. I'll reply to both. Good luck with the questions. There will be some exam practice this week, so we're going to do some work on wages and overtime. I'll post that video later in the week, and there will be another Pythagoras video probably on Thursday as well. Okay, good luck, and if you have any questions, you know where to contact me.